Hello there, Mr. Sutton here, bringing you the IM371 Extra Practice Number 1 solutions on the Pythagorean Theorem. To find the missing side of this right triangle, since we already have two of the sides, we can use the Pythagorean Theorem. So that's a squared plus b squared equals c squared. And now I always check out the c value first. That's the side that's across from the right angle, the hypotenuse. That's this x side here. And then a and b will be these other two sides. So plugging in some sides, I'll write 7 squared plus 14 squared equals x squared. And then let me add up the stuff on the left side, and I'll use the calculator for this. So that comes out to 245. All right. And if I square root this, well, I know 245 is not a perfect square. So I am going to have to try to simplify this radical. So are there any perfect squares that do go into 245? Well, I don't know about perfect squares, but at the very least, I know 5 goes into 245. Goes in, let's see, 5 goes into 250 50 times, so it goes into 245, 49 times. Well, that's convenient, so I can actually split this up into radical 49 times radical 5. And that's just going to be 7 radical 5. On this problem, I'm trying to find this missing side of the right triangle. Since I've already got two sides, I can use the Pythagorean theorem for this. So let me start with a squared plus b squared equals c squared. And let me see what the c value is before I plug in a and b, because c is the only one that you can't interchange. So that's going to be the hypotenuse across from the right angle. Here's the right angle, so 15 then is our long side, our c side. And then that means a and b are the other two sides. So I'm going to write 5 squared plus x squared equals 15 squared. And I need to get x by itself by subtracting 5 squared over to the other side. 15 squared is 225, so we're subtracting 25 from that. So that means x squared must equal 200. And now I can square root both sides to find that missing side. But I need to put this in simplest radical form, and 200 is not a perfect square. But I can split it up into a perfect square. So I could split this into 100 times 2, so square root of 100 times 2 then, if I take the square root of both sides. And then that simplifies to 10 radical 2. To find the missing side in this right triangle, we're going to use the Pythagorean theorem since I already have two sides. So we've got a squared plus b squared equals c squared. And c, the hypotenuse, is going to be across from the right angle. So that's this x side right here. That means that a and b are these other two sides. So I can write 4 squared plus 6 squared equals that third side, x squared. And let's see here, we've got 16 plus 36, which is 52. Now I have to square root both sides to find x. And I'm going to put this in simplest radical form. So 52, the biggest perfect square I can think of that goes into that is 4. 4 times 13, so I can write radical 4 times radical 13. And then that simplifies to 2 radical 13. To find the area of this triangle, we're going to use 1/2 base times height. We've already got the base, it's 5, but we need this height here. Since this is a right triangle and we already have two sides, we can use Pythagorean theorem to first find this height and then use that in our area formula. So let me start with that theorem, a squared plus b squared equals c squared. And just so I have something to refer to when I'm talking about the height of the triangle, I'm going to call this h over here. So using Pythagorean theorem, I see that c is going to be this 9 side across from the right angle. So then a and b are these other two sides. So I can write 5 squared plus h squared equals 9 squared. 9 squared is 81. 5 squared is 25. I'm going to subtract 25 from 81 to get h squared by itself. So let's see here. That's going to be 56. And then let me square root that. I'm actually going to square root that on the calculator and round it off to the nearest tenth. And then I can use that value in my area formula. So here we go. I've got the square root of 56, which is 7.5 if I round that off. So now we've got area equals 1/2 base times height in general. The base we said was this 5 down here. For the height, that's this 7.5 that we just found. And let me multiply that out on the calculator. So we've got 0.5 times 5 times 7.5, giving me, if I round that off, 18.8. On this problem, I'm trying to find the area of this isosceles triangle. So in order to get the area, I need the base and the height for 1/2 base times height. The base is not 3.8. That's actually the base of one of these half triangles. We know it's a half triangle because this is isosceles, and we know that we've got the same measurements over here as we do over on this other side. So we do know that this other little mini base here is also 3.8, which means I can double the 3.8 to get the base of the whole isosceles triangle. So we'll do that down the road. We also need the height, though. In order to get the height, it helps to think of this as being one side of a right triangle. We've got two right triangles, actually. We just need to analyze one of them. And since I already have two sides of this little half right triangle, the 11 and the 3.8, I can use the Pythagorean theorem to get this third side. So I've got a squared plus b squared equals c squared. And the c value in this right triangle, across from the right angle right here, that's going to be this 11 right here. So these other two sides are going to be a and b. Now let me call this height here h, just so I can refer to it quickly. And now with Pythagorean theorem, I can write 3.8 squared plus h squared equals 11 squared. At this point, I need to get h squared by itself and then square root. So let me do 11 squared minus 3.8 squared on the calculator. So that's going to come out to, let's see, 106 I'll round that off to 0.6. Just as an intermediate step, they said round to the nearest tenth for those. And then let me square root that to get the value of h. So going back to the calculator, we've got square root of 106.6 coming out to about 10.3. So that's the h we'll be using in just a moment. So we've got 1/2 base times height in general. The base in this one is going to be 2 times this 3.8. Again, this is isosceles, so we just double this half base to get the whole base. So 2 times 3.8, that's all the base. And then the height is this 10.3 that we just found. So on the calculator, you'll notice that we have a 1/2 times a 2, which actually is just going to cancel out. So we really just have 3.8 times 10.3. Let me go back and do that. And crunching those numbers on the calculator, I get about 39.1 if I round off to the nearest tenth. To figure out whether this triangle here is a right triangle, we need to see if it satisfies the Pythagorean theorem. So a squared plus b squared equals c squared. Just plug in the numbers basically and see if it comes out the same on both sides. So when you're doing this, the c value has to be the largest of the three values because the hypotenuse is always the biggest side of a right triangle. And then a and b will be the smaller two sides. So we can write 80 squared plus 84 squared equals, question mark, 116 squared. Well, let's use the calculator and see if that is the same. So 80 squared plus 84 squared is 13,456. And how about 116 squared? It's got potential because it ends in a 6. So let's see, 116 squared, that comes out to the exact same thing. Well, how about that? Since these two sides come out exactly the same, this proves that yes, this is a right triangle. For this problem, we want to know if this is a right triangle. To prove it one way or another, we're going to have to plug these sides into the Pythagorean theorem. So that's a squared plus b squared equals c squared. And for a and b, I have to use the shorter sides, and then c is the longest side, because that would be the hypotenuse. So I can write 36 squared plus 77 squared equals, and this is a question mark equals, 84 squared. We'll see if it comes out the same on both sides. Let's use the calculator. Crunching the numbers for the left side of that equation, we get 7,225. Well, I don't think 84 times itself is going to give us something ending in a 5, but let's just see what it does give us. I'm kind of curious here. So 84 squared, that comes out to 7,056. So yeah, definitely not the same number. This proves that the triangle is not a right triangle. On this one, to prove if we've got a right triangle or not, we're going to see if these sides satisfy the Pythagorean theorem. A squared plus b squared equals c squared. So basically just plug the sides in and see if it comes out the same on both sides. So let's see here. 170 is going to be our C value. That's going to be the hypotenuse, the longest side of the triangle. And then A and B, we can use 80 and 150. So we have 80 squared plus 150 squared equals 170 squared. And I'll put a question mark at the end of that because we're not sure. Let's use the calculator to see what it all comes out to. So 80 squared plus 150 squared, that's going to be 28,900. And then how about 170 squared? 170 squared. And let's see, that's going to come out to 28,900. Well, since those two sides are the same, that means that yes, this is a right triangle.